Hello everyone, welcome to Hacker Heap. In this video, we will look into solving the problem surrounded origins. Before we start, please do like and subscribe to the channel Hacker Heap. Let's look into the problem. So given a 2D board containing X and O, capture all the regions surrounded by X. A region is captured by flipping all O's to X in the surrounded region. So in the given example, it should result in this, which means all the border O's cannot be flipped to X, and any O's that are connected to the border O cannot be flipped to the X. This example doesn't explain everything. So let's look into this example where I have a 5x5 array O, X, 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 and I have X, O, O, X, 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 O, O, O. So taking this array, what we need to return is, so these cannot be changed to X because these are connected to the border. Only this can be flipped to X. So the result array should be this, and this should still remain as O's. So how do we do it? So if you are aware of islands problem, it's kind of an islands problem with a little twist to it. All we need to do is we need to find all the connecting O's that are to the border and make sure they are not flipped. So first we will process those by doing a depth first search. Let's say if we find a border O, we will find if there are any connected O's, and what we will do is we will replace with something like hash so that we don't flip it to X. Once we replaced all the O's connected to the border, what we will do is we will replace the middle O's to X so that we will get the final output. So let's see what I'm talking about. So we have this matrix 0x, x, 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 0x, x, 0, 0, x. So now we will pass through the border. When we find this O, what we will do is we will find what are the connected O's. So we find this and we find this. We will convert these to O's. So once we hit all X's on the surrounding, we will just return. Now we will go through all the things. So if we find an O, we will turn it to X, and if we find a hash, we will turn it back to O. So the resultant array would be this. O, X, X, O, O, X. First we flip the O's to hash, which are connected to the borders, and then we will flip the original O's. That's how we do it. Let's go ahead and code it out. So first thing we need to check is if board is equal to null, we'll just return because there is a void return. So we will get the rows and columns, int m is equal to board dot length, int n is equal to board of 0 dot length. Now we will look into the leftmost column and the rightmost column. And I is equal to 0, I less than m, I plus plus. If board of 0 is equal to O, we will do a depth first search of board comma I comma 0. And if board of I comma n minus 1 is equal to O, then we will do DFS of board comma I comma n minus 1. So we are checking the leftmost column and the rightmost column. We need to check the top row and the bottom row. Check top row and bottom row. I is equal to 0, I less than n, I plus plus. If board of 0 comma I is equal to O, we will do a DFS of board comma 0 comma I. If board of m minus 1 comma I is equal to O, we will do a DFS on it. Board comma m minus 1 comma I. So what we are doing here is, if we have this array of 3 by 3, we are checking here, we are checking this column and this column, so that we are checking the borders of left and right, and here we are checking this top row and the bottom row, making sure if there are any O's, we need to do a DFS and make sure we flip them to hash. So now once we had it, we need to write this function DFS, like void DFS of char board comma int I int j. First thing we need to do is we need to flip that O to hash. Board of I comma j is equal to hash. Now let's define an array so that we do +1 and -1 for all the 4 sides. We need to check all the 4 sides too. We will initialize arrays so that it will make our life a little bit easier. Int tx is equal to 0, and for the y index dy is equal to 0, 1, 0, -1. Now what we will do is for int I is equal to, k is equal to 0, k less than 4, because there are 4 sides for each index, k plus plus, int x is equal to I plus dx of k, and similarly we will get the y index is equal to I plus dy of k. Now we got these 2 indices. We need to check if they are not out of the bounds, like if x is less than or equal to 0. We need to make sure if it is x is greater than or equal to 0, because the indices starts at 0 and it is less than the length of the board. X greater than or equal to 0 and x less than board dot length, and y greater than or equal to 0 and y less than board of 0 dot length. And we need to make sure board of x comma y is equal to O. What we need to do is we will do a DFS of board comma x comma y. That is it. So all we are doing is we are checking if there is an O in the border and if there are any connected O's to that particular O. Once we are done processing DFS, this array 0 x x x x x 0 0, this array would look like this: x x x x 0 x x x x x hash hash, because we are replacing the connected O's in the border to hash. So this will look like this. So all we need to do is we will go through each element and flip O's to x and hashes back to O. Now process. For int I is equal to 0, I less than m, I plus plus, int j is equal to 0, j less than n, j plus plus. If board of I j is equal to O, board of ij equal to x, else if board of I and j is equal to hash, we will flip it back to O. Oh, that is it. So let's go ahead and run. This is an array, my bad. Yeah, submit. Okay, I need to check it's not empty, or board dot length is equal to 0. Okay, I think what I'm doing is here, it should be j plus dy of k. I did it wrong. Yeah, it went through. Let's look one more time what we did. All we did is the given array is this. So if this is the given array, what we are making sure is we will check if there are any O's in the left and right columns, left and right borders, which in this case there are no, and we will check if there are any in the top and bottom. When we find this O, what we are doing is we are making sure if there are any connected O's and flipping them to hash. So when we find this O, we are calling this DFS function, which will, in the first iteration, this would convert into this x0xx xx0x xx hash x. And what we are doing is, again, we are checking all the 4 sides, and if there is an O, we are calling the DFS again, and we are converting this to hash in the second iteration. And then we will check 4 sides for this hash. These are the 4 sides. We didn't find O, we would just return. Once we got this array, we are processing it and making sure if there is an O, we are converting it to x. So this will result into xxxx xxxx xx, and we will convert hash back to O, x x x o x. So this is the expected output. I hope it's clear. Please do like and subscribe to the channel Hacker Keep. Thank you.